DOH-NANI from the Department of Statistics and Actuarial Science, KUniversity, Kumasi, Ghana. Today we are just continuing with what we earlier did in the previous video. So we are still talking about trigonometric ratio and rules. Now we are going to talk about some cases or some trigonometric ratio cases. So without wasting much time, I just want to let you know some cases as far as trigonometric ratio is concerned. So case 1. So when an angle is formed, and in this case the angle lies between 0 degrees and 90 degrees, which happens to be the acute angle, as we said earlier in the first video. Then we can boldly say with the trigonometric identity, all of them are positive. What do I mean here? Now, as I said earlier in the first video, considering the two-dimensional plane over here, we said that from the origin upwards is positive. So is the origin to the right is also positive. Now our acute angle is formed in the positive planes, or where in both planes or in both directions they are all positive. That's where our acute angle is formed, or that's where our right angle triangle can be formed. And I said earlier, trigonometric ratio has to do with where the acute angle, or on the side where the acute angle can be formed, or the right angle triangle can be formed in a circumference. So here, considering our R to be a unit length, then it means that basically, if we want to find for sine theta, then sine theta is y over r, and that is y, because our r here is said to be a unit length. So with our x, x over r will be x, and finally y over x will be positive y over x. Why? So when you measure a distance over here, and where x represents any value, it is always going to be positive because it's falling at the positive plane, or the positive side. So the y will be. So here, that is the reason why we are getting positive wherever we go for the case 1. So when you take any value for the theta, say 20, 30, 40, and any angle that falls between these values, this 0 and 90 degrees, you are going to always get positive, whether using the cos, the sine, or the tan. Now to case 2. With the case 2, it's an angle that fall between the 90 degrees and then the 180 degrees. And you remember that such angle is said to be called an obtuse angle. And this is the angle theta. Now, as I said earlier, trig ratio has to do with where on the side where the right angle triangle is formed. And the right angle triangle can be formed over here. Though an angle theta measured from the origin to this place is more than 90 degrees and less than 180 degrees, we consider where the right angle triangle is formed. That is x and y forming. And now here we can get the sine to be y over r. The sine theta is y over r, and it is positive. The reason being is that the y is a distance moving towards moving upwards from the origin when we consider the y plane, and it is positive. But for the x, it is moving in the negative direction. So there is a negative sign here. It's moving in the negative direction from the origin, and thus x will be said to be negative, though the distance distance, the distance is not negative, but to the direction where it lies. That is why we add negative to it. So here we have the cos theta to be negative x over r. So we finally get cos to be negative. Now we said tan theta is what? Y over x. So tan here is y over x. Okay, so yeah, let me just correct this. I'm considering alpha degrees here. I'm considering alpha, in this case, I'm considering alpha degrees over here, not theta, because to find for alpha degrees, we need to do some deduction. That is 180 degrees minus the theta. So, example, if if you are given a theta degree to be, say, 125 degrees, then we have our alpha to be equal to 180 degrees minus 125, giving us 55 degrees. And so if I find sine of 55 degrees, it is the same as sine of 125 degrees. Well, you can use your calculator and check at home. In the same way, if I'm going to use cos using the alpha degrees, then I'm going to add negative cos of what? 55 degrees is equal to the cos of 125 degrees. Why? In this case, I'm adding the appropriate sign to the cos to this very angle, the smaller angle over here. I'll just add the appropriate sign to the identity. And it will give me the same answer. It will give me exactly as the same answer the cos 125 gives me. Finally, for the tan theta, so tan alpha is 55. Is equal to tan of what? 125. But in this case, we will add negative. Why? Because considering tan, we said it's y over what? Tan alpha is y over what? X. Y over what? X, opposite over the adjacent. But our opposite is positive though, but the adjacent is falling at the negative, so making the whole ratio a negative. So the negative of tan 55 gives me the same answer as tan 125. You can cross check with your calculators. Now we are going to consider the case 3 or the third case, and in the same way we are also going to consider alpha degrees. Sorry for that, alpha degrees. And now what can we find over here? We can see that our alpha is forming between 180 degrees and 270 degrees, as it has been suggested or it has been written over there. Now our angles are given, angle theta is given, maybe you can probably say 190, 207, 210 or so on, or any other angle that falls between 180 degrees and 270 degrees. But here is our right angle triangle forming. So we can see that our x is though a positive distance, but for the direction it is falling at the negative direction. In the same way, our y is also falling at the negative direction. The distance y may be positive, but for the direction is negative. So for sine of theta, we are going to get y over r. And I said earlier that our r is a unit distance, and henceforth we are going to get y, negative y. Why? Because y is moving at the negative direction. And also for cos alpha, we're going to get negative x on r, because x is any value, or a distance x is any value, but for the direction towards the left side is negative, so that makes it negative. But here for the tan alpha, we said if tan alpha is y over x, or the opposite over the adjacent, we are going to get negative y over what? Negative x, making then the negative cancels each other, then we get positive over here. So for the alpha, the angle alpha, we can get the angle alpha by just deducting 180 degrees from the angle. So if we are given an angle theta to be, say, 210, so when we subtract our alpha degrees is equal to 210 minus what? 180, which is basically alpha degrees equal to 30 degrees. Just 30 degrees. So you can go through the same procedure as I did over here and adding the appropriate sign as it has been stated over there, and you get the same answer for both in all directions. Finally, the case 4. We are going to talk about the case 4. So with the case 4, the angle is formed between the 270 degrees and then 360 degrees, and we can find out that our angle alpha degrees, or the right angle triangle, is formed at the fourth which lies between 270 degrees, as I said earlier. So with the sign of theta, so sorry, here should be alpha degree. Here it's going to be alpha degree and also alpha degree, where our alpha degree is defined by 360 minus the angle given theta minus the angle theta. And as I said earlier from our first video, we said that it's a reflex angle. So for sine of alpha degree here, we know that the y is moving towards the negative pole, or the negative direction. So distance y is made negative. The distance y is negative. So here sine will be negative. And in the same way, cos. The cos is x. You get it, over the unit distance r. So we are going to get a positive. We're going to be positive because it's moving towards the positive direction. And the tan theta here is going to be negative and then positive. So finally we're going to get negative, giving us negative y on x. So here at the fourth quadrant, we can find out that here it is only cos that is positive over here. It's only cos that is positive. So if you have any angle, say if angle theta is given to you, say 330 degrees, given 330 degrees, then your alpha degrees is basically 360 degrees minus 330. Then you get 30 degrees. Then you work it out, and you will get the same answer as you get, say, sine alpha, which is 30 degrees. Sine alpha, which is 30 degrees, is the same as sine 330 degrees. But in this case, you have to add negative to the sign, the appropriate sign, to the sine to the alpha degrees, and you do same for the remaining ones, and you get the same answer. Now, there is a mnemonic called a cast. This cast is basically where the trig identity, the positive ones, where they lie. So when you say all of them are positive, as I said earlier, when they are at the first quadrant, all of them are positive. But when we consider the second quadrant, it is only sine it's only sine alpha is positive. It's only sine alpha is positive. And that is at the second quadrant. When we talk about the third quadrant, it's only tan theta or tan alpha is positive. It's only tan alpha is positive. And finally, cos, cast, or cos on the fourth quadrant. That is it. On the fourth quadrant, it's only cos alpha is positive. So we basically use C to represent cos. All of them are positive, and sine is positive at the second quadrant, and tan is positive at the third quadrant. So that's what we refer as cast. So thank you very much.